See, first, what do you mean by a probability? Generally, we define as in normal parlance, it is study of chances. So, for example, when you go to a movie, a newly released movie, you try to get a ticket. So, therefore, whether you may get it or you may not get it. We say the chances are half. That means whenever I ask you probability or a chance, we say some number of we say. This is a very common word we use. So therefore, probability actually can be defined like this. It gives a quantitative description of likely occurrence of an event. That is what probability is. Before learning probability definition, we shall learn few words like random, experiment. So we shall see what is this. An experiment which can be conducted any number of times. The possible outcomes are known, but exact result cannot be predicted. Means an experiment which can be conducted any number of times, the possible outcomes are known but exact result cannot be predicted. Example, tossing of a coin. Before we toss a coin, we know the outcomes, either head or tail we are going to get, but exactly we cannot say what is the result of the experiment when you toss a coin. We know the outcomes, but we cannot say exactly. Similarly, throwing of a die. Here also we know the possible outcomes 1, 2, 3, 4, 5, 6, but when you throw it, we cannot say exactly what number we are going to get. Therefore, it is called a random experiment. Chemical experiments are not random experiments because we are not sure what the products are before we start the experiment, and the result once we get has to be detected or has to be analyzed for confirmation. So therefore, without having an idea of outcomes, it is not called a random experiment. Next one, random events. So the list of all possible outcomes is called random events. Means when you toss a coin, the possible outcomes are, you make it like this: 4, 3, 6, 5, 1, 2. So these are all the possible outcomes, let us say. The numbers may not be in order, but you never get any outcome other than any one of the number given in the set. So therefore, when you throw a die, the possible outcomes are 1, 2, 3, 4, 5, 6. The list of all those outcomes is called random events. Next Next one is elementary event. So here I can define like this: an event corresponding to one of the random events is called elementary event. Therefore, if you see the random events, 4 is there. 4 is called elementary, 3 is called elementary, 6 is called elementary, 5, 1, 2. Each one is called an elementary event. So therefore, an event corresponding to one of the random events. Random events means it consists of a group, a set of numbers, a set of objects. An event corresponding to one of them is called elementary event. Next definition is event. So event can be defined as one or more elementary events is called any event. Suppose if I ask you a question, what is the probability of getting a prime number? I am asking the prime number probability. Suppose if I take numbers from 1 to say 100, we have many prime numbers. So each one is called elementary event. But set of all prime numbers, it is an event. Means it is, when you calculate a probability, we take a set of favorable events. So that set of events is an event of prime number. So event means it may contain one or more elementary events. So we learnt random experiment, random events, elementary events, event. Another one is mutually exclusive events. So here we can define like this: mutually exclusive. So when both the events do not occur simultaneously, they are called mutually exclusive events. Suppose I take an example, or sometimes we can define mutually exclusive events as what I can say dependent events, because dependent events do not occur simultaneously. Such events are so called mutually exclusive events. We can define like this: an event or I can write I can put it like this: occurrence of an event prevents occurrence of another event. Then these events are called mutually exclusive events. That means both the events do not occur simultaneously. I take one example like this: getting first rank is mutually exclusive. Why? Because if a person is getting first rank, he prevents others not to get the first rank. That means we can say here a person getting first rank prevents others not to get the first rank. First rank can be given to only one person, not more than one. So therefore, if a person is getting, he prevents another person getting the rank. Hence, mutually exclusive events is first rank. Whereas I take another example like getting first class is not mutually exclusive. Why? Because a person getting first class cannot prevent another person getting the first class. Therefore, getting first class is not mutually exclusive. So, getting first class is not mutually exclusive. So, therefore, we can say here mutually exclusive events are events which do not occur simultaneously. We take next definition. So I take the next definition, equally like. Events which have equal chance of occurrence are called equally likely events. See what we mean by this? Say, we conduct a test for a class. Everyone is given same question paper, same questions, or I can say same time duration. Now all of them are given equal chances to get the first rank. Therefore, I can say getting first rank is equally likely event because anybody in the classroom have equal chance of getting the first rank. So such events are said to be equally likely events. I take another example. Suppose when I throw a die, what is the chance of getting 1? It is 1 by 6. Similarly, chance of getting 2 is also 1 by 6. Similarly, for getting 3, 4, 5, 6, 1, each one they have a chance of getting, probability of getting 1 over 6. Therefore, all the number they are equally likely to occur. Such events are said to be equally likely events. Now, after learning this, we can see what is probability. Let us say I write probability. Suppose there are n equally likely mutually exclusive events. Suppose there are n equally likely mutually exclusive events, and out of which m are favorable to an event, then probability of the event is defined as follows. Equivalent to number of favorable event by total number of events. So therefore number of events, favorable events are m, total number is n. So therefore probability of the event is defined as m by n, and out of n, m are favorable. Therefore events not favorable or n minus m. Also define probability of E dash, where probability of not occurring an event is defined as n minus m, because which are not favorable to occurrence of E, by total number of events. Therefore I can write n by n minus m by n. This can be 1 minus, where m by n is PE. Hence I can write here PE plus PE dash equivalent to 1. This is the basic definition for probability. So now we consider probability of an event is always lies between 0 and 1. If PE equivalent to 1, it is called as certain event. Example, what is the probability of getting a natural number when you throw a die? Now whenever you throw a die, always you are getting some number which is a natural number. Therefore we can say in this case the probability is 1. If PE equivalent to 0, it is called impossible event. Example, if I throw a die, what is the probability of getting number 7? You throw any number of times the die, you never get number 7. Therefore it is called an impossible event. Now we can see another definition, odds in favor. Let us say if PE equivalent to 3 by 5, this implies PE dash equivalent to 2 by 5. Hence odds in favor of an event E is defined as PE is to out of 5 outcomes, 3 are favorable to E and 2 are favorable to E dash. This is called odds in favor. Similarly, odds against, actually we call it as a ratio, odds in favor ratio, odds against ratio is defined as PE is to P dash is to PE. So that is equivalent to 2 is to 3. So this is about odds in favor ratio. See the question. 7 people are seated in a row. We have to find the probability that 2 particular persons are seated at the ends. Now we considered 7 places for 7 people. So first we have to fix particular persons at the end, like here A and B, and the remaining 5 people can be arranged in between in 5 factorial ways. But A and B themselves can be arranged again in 2 factorial ways. That means A first at the end B, or B first and A at the end. Therefore, the number of arrangements equivalent to 5 factorial into 2 factorial. But we have to find the probability that these 2 persons. Therefore, now the sample space, that means the arrangement of 7 people in a row is 7 factorial. Hence, probability of the event having A and B at the ends is given by 5 factorial, which are favorable events, into 2 factorial by 7 factorial. So that is equivalent to 5 factorial into 2 factorial by 7, 6, 5 factorial. Cancelling 5 factorial and 5 factorial, equivalent to, this is 2 into 3, so 1 by 21. Hence answer is B. To find probability of getting 53rd Sunday in a year. A normal year contains 365 days, whereas leap year consists 366 days. That means it consists exactly 52 weeks. 52 weeks and 2 days more. So these 2 days can be any 2 days in a week. That means it may be Sunday, Monday, or Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday. So therefore we have 7 possibilities, out of which 2 contains Sunday, that is the first one and the last one. So therefore the probability of getting one more Sunday here is, out of 7 any one will occur, hence 2 favorable events by 7 the possible outcomes. Therefore the answer is B, that is 2 by 7. Above question, we have to find the probability of drawing a king from both the packs. First, each pack contains 52 cards, in which we have 4 kings from 4 suits. A suit means which contains 13 cards. So totally 4 suits, each one 1 king. Therefore 4 kings are contained in 1 pack of cards. Therefore the probability of drawing a king from first card is 4 by 52. Again from the second card is also 4 by 52. So we have to draw a king from both the cards, therefore multiplication into. Hence the probability of the event, that is drawing a king from both the cards, is 1 by 30 1 by 30 after simplification is 1 by 169. That is, A is the answer. This question, 2 dice are rolled simultaneously, then we have to find the probability that the product of two numbers on 2 dice is 12. When 2 dice are rolled, the sample space is means the maximum outcomes. That is, each die can happen in 6 ways. Therefore, 2 dice in 6 into 6, 36 possible outcomes are there. Out of these 36, we have to choose those outcomes. The product of two numbers is always 12. So therefore, first we can list out the product of two numbers whose product is 12. So first number 2, the other number can be second dice may be 6, the product is 12. Similarly, 3 on the first die, 4 on the second die, the product is 12. Again 6 on the first die and 2 on the second die, the product is 12. So therefore totally we have 12, and other possibilities are 12. So we have one more possibilities where we can get 12, 12. Another one here we can write 4 into 3. So that I have forgotten. So therefore total here the favorable events are 4. Therefore probability of the event equivalent to 4 by sample space 36, that is 1 by 9. Answer is D. To find the probability of drawing a white, black and red ball. So here, as it contains 3 white, 2 black and 6 red balls, we have to draw 3 balls at a time. Therefore the sample space, that is possible outcomes, are as it contains total 11 balls, 11C3 is the sample space. But we want 1 white, 1 black and a red ball. Therefore the favorable outcome should be 3C1, 2C1, 6C1. This is a favored outcome. Hence probability of the event, that is drawing 1 white, 1 black and 1 red, is 3C1, 2C1, 6C1 by total number of events, that is sample space 11C3. So by simplification we get 12 by 55. So that is A is the required answer. Probability of drawing a white, black and red ball. So here, as it contains 3 white, 2 black and 6 red balls, we have to draw 3 balls at a time. Therefore the sample space, that is possible outcomes, are as it contains total 11 balls, 11C3 is the sample space. But we want 1 white, 1 black and a red ball. Therefore the favorable outcome should be 3C1, 2C1, 6C1. This is a favored outcome. Hence, probability of the event, that is drawing one white, one black and one red, is 3C1, 2C1, 6C1 by total number of events, that is sample space 11C3. So by simplification we get 12 by 55. So that is A is the required answer. To find the probability of drawing either in a spade or an ace. The number of cards are 52. Out of them, spades, which is the name of a suit, contains 13 cards. In these 13 cards there is an ace, and again ace means one in each suit, totally 4 aces in 52 cards. But we have to find the probability of drawing either a spade or an ace. But we have a card which is both spade and ace. Therefore, using the set theory, we have to write the probability of A or B. Let us say A stands for spade and B stands for ace. Then PA plus PB minus PA intersection B. Here both the events A and B are independent of each other, means occurrence of spade do not influenced by ace. Therefore, the probability of drawing a spade here is 13 by 52 plus probability of drawing an ace is 4 out of 52 cards minus there is a card which is both spade and ace, therefore 1 by 52. Simplifying, we get here 16 by 52, therefore 4 by 13. Your answer is C. Question: we have to find odds in favor of being all blacks. First, the total number of balls given are 9, of which 5 are black. When you draw 3 at a time, then the sample space is 9C3. So these are all possible outcomes, of which getting all the blacks at a time is 5C3. So therefore getting all black at a time is 5C3. Therefore probability of getting an event where all the 3 balls are black is 5C3 by 9C3. The odds in favor is defined as P is to PE dash. Therefore, PE is 5C3 by 9C3 is to PE dash can be calculated 1 minus 5C3 by 9C3. Simplifying the above question, we get here is 5 by 37, hence your answer is D. And we are given cards numbering from 5 to 21, means total number of cards is 17. We draw 3 cards at a time, therefore sample space is 17C3. When you add the numbers on three chords, the sum should be a prime number less than 22. Let us consider prime numbers less than 22. That is, given chord begins with 5, so 5, 7, 11, 13, 17, 19. So these are the prime numbers, and the given numbers are 5, 6, 7, 8, 9 up to 21. So when you draw three chords at a time, the sum should be a prime number. Let us consider the sum of least numbers, that is 5 plus 6 plus 7, that is equivalent to 18. So therefore, if you add any three chords, you will always get a number more than 18, not less than 18. Therefore, there is only one prime number more than 18 and less than 22, that is 19. So this is possible only when you add 5 plus 6 plus 8, that is 90. Hence, probability of getting the event, that is a prime number less than 22, is only one favorable event, that is 5 plus 6 plus 8. Therefore, one favorable event, and sample space is 17C3. So simplifying, I get 1 by 680, that is C is the answer. And the probability of a number greater than 2000. We are given 4 numbers, and these numbers can be arranged, that is sample space is 4 factorial by 2 factorial, because 0 repeats twice. Hence, I can write here 24 by 2, that is 12. So there are totally 12 possible outcomes, in which how many are there which are greater than 2000? Let us consider 4 places for 4 digits. Since the number should be greater than 2000, the 1000th place should be 2 or more. Therefore, we can fill only 2. That means only one way. So actually 2 indicates only one way of filling it, and remaining 3 numbers can be filled in 3 factorial, and out of these 2 zeros are there. Therefore, the number of arrangements where, that is numbers greater than 2000, is 3 factorial, because 2 is the only one way of writing, and remaining 3 places 3 factorial by 2 factorial, that is 6 by 2, that is 3. Hence, only 3 numbers greater than 2000. Hence, probability of the event equivalent to 3 by 12, that is sample space is 12. Hence, 1 by 4. Therefore, A is your answer. Given 1 white and 1 black ball. We have to find what is the probability of getting a black ball in the second draw. Now, as it contains only 1 white and 1 black ball, if you draw first ball, if you draw black ball in the first draw, it is not replaced, and therefore we won't get black ball in the second draw. Hence, the first draw should be white. So therefore, for getting white ball in the first draw, that is the probability of even getting a white ball in the first draw is 1 by 2. Now we replace this ball with another white ball, hence it contains totally 3 balls. Now drawing the ball, black ball in the second draw is, I can write probability of drawing black ball in the second draw, let me here, is 1 by 3, because once you get white in the first draw, we have replaced the ball with another white, hence it contains totally 3 balls. When you get second ball in the second draw, we draw it out of 3, therefore the probability is 1 by 3. Hence the required probability is 1 by 2 into 1 by 3, that is 1 by 6. Means first we should get white ball, that is 1 by 2, into second we should get black ball, that is 1 by 3. Hence it is 1 by 6. Therefore your answer is B. Number of glass vase given are 15. In those, defective are 3 and good one are 12. The question, the 6th draw should be the defective one, last defective one. Means in the previous 15 draws we should have 2 defective and 3 good pieces. Hence in the total 5 chances in the previous 5 draws, the sample space is 15C5. In this 5 we should have 2 defective and 3 good. Therefore the number of ways of getting ways of getting 3 good and 2 defective is 12C2 and 3C2. 3C2 and 12C3. See, therefore here we get in all the 5 chances 3 good and 2 defective. So to get above result, the probability should be 12C3 into 3C2 divided by 15C5, which is sample space. So this will result into 20 by 91. After 5 draws, we are left with 10 glass waves which contain only one defective piece. Hence, getting the defective in the 6th draw is, the probability of getting in the 6th draw a defective one is 1 out of 10, that is 1 by 10. Hence, required probability means in the first 5, what I can say, draws, we should have got 3 good and 2 defective, and hence in the 6th draw, last defective should be 20 by 91 into 1 by 10. Simplifying, I'll get 2 by 91. Therefore your answer is, find the probability that the student has passed only in one subject. First consider the probability of passing in mass is, let us 60 by 100. Similarly, probability of passing in stats is PB equivalent to 60 by again 100. Similarly, probability of passing in both, right here, A intersection B, that is both 30 by 100. We want probability of passing either in maths or stats and not both. Therefore, PA union B equivalent to PA plus PB minus PA intersection B. Substituting the values, 60 by 100 plus 60 by 100 minus 30 by 100. So that should be equivalent to 120 minus 30, that is 90 by 100. So after simplifying we get 9 by 10, hence your answer should be B. Probability of solving a problem by A is 2 by 5, means PA dash not solved by A is 3 by 5. Similarly, probability of solving question by B is given as 1 by 5. This implies not solved by B is 4 by B. Similarly, probability of probability of solving problem by C is 3 by 7. This implies not solved by C is 4 by 7. The question here, we have to find the probability of the problem solved, means it may be solved by A alone, B alone, C alone, or AB, AC, BC, or ABC. Therefore, first we shall find what is the probability of not solving by anyone, of not solving the problem by anyone, equivalent to 3 by 5, 4 by 5 into 4 by 7. Hence this should be equivalent to 48 by 175. So the above probability gives problem not solved by anyone. Therefore, the required probability means solved by at least one. Required probability is 1 minus 48 by 175, that is equivalent 127 by 175. Hence your answer, when a coin is tossed, you will get either hit or a tail. If we get hit, a dice are rolled and the sum of it is noted. If tail, the card is drawn from a pack of cards. So in both the cases, whether you dice are rolled or card is drawn, it should be either 7 or 8. Therefore, let us consider the probability of getting it equivalent to 1 by 2. So then dice are rolled. When 2 dice are rolled, the sample space is 36. Out of all possible 36 outcomes, the sum should be either 7 or 8. To get 7, 1, 6 on second die, sum is 7, 2, 5, 3, 4, 4, 3, 5, 2, other possibility 6, 1. So total is 6 outcomes where the sum is 7. Again, to get a sum 8, it can be 2, 6, 3, 5, 4, 4, 5, 3, 6, 2. So totally 11 outcomes out of 36 where the sum is either 7 or 8. So here the probability of getting 7 or 8 is probability of getting 7 or 8. That means the sum 7 or 8 is 11 by 36. This is in case if we get head. Suppose if we get tail, let us say the probability of getting tail is again 1 by 2. So here when you get tail, we have to draw a card from pack of cards. So it should be either 7 or 8. Either 7 or 8. Therefore, we get only probability of getting 7 or 8 is 2 out of 12 cards. So therefore, that is 1 by 6. Hence, the required probability equivalent to 1 by 2 into 11 by 36 plus 1 by 2 to 1 by 6. That should be equivalent to 17 by 72. Hence, your answer is C. We have to find the probability that the number is divisible by 5 or 7. Sample space in this case is, that means total numbers given is 200, because we are taking only one number at a time. This is total 200 numbers, therefore sample space is 200. The numbers which are divisible by 5 are numbers which are divisible by 5 or 40. Similarly, numbers which are divisible by 7 or 28. Also, the numbers which are divisible by 5 and 7, that means both are 5. So therefore, we have to find the probability divisible by either 5 or 7, not both. Using the set theory, I can write P A union B, where A is the probability of getting a number divisible by 5 and B PB is the probability of a number divisible by 7. Then PA intersection B gives the probability that number is divisible by both. Therefore, PA equivalent to 40 by 200, PB equivalent to 28 by 200 minus 5 by 200. Hence, it is equivalent to 63 by 200. Hence, the required answer is A. We have to find the probability of selecting 4-digit number out of all digit possible numbers which can be formed out of given digits 1, 2, 3, 4, 5. First, let us find sample space. So in this case, sample space means we have to find sum of 5-digit numbers, that is 5 factorial, plus 4-digit number out of 5, that is 5p4, 3-digit 5p3, 2-digit 5p2, again 1-digit 5p1. So the above sum will give you all possible numbers from 1 digit to 5 digits. Out of this, we have to find the probability of selecting a 4-digit number has to be found. So therefore, probability of the event, that means selecting a 4-digit number, that is 5p4 by 5p1, 5p2, 5p3, 5p4 and 5 factorial equivalent to 120, and this simplifies to 325. So equivalent to 24 by 65, where B is the required answer. There are 4 people. We have to find the probability that no 2 of them born on the same day. First, let us consider the first person. Since he is the first, he can born on any day because no other person has born before him. Hence, there is no, what I can say, chance of taking birth on same day. So therefore, for first person, the probability would be any 7 days he can born out of 7, therefore 7 by 7. And for the second person, he cannot born on the day on which first person has born. Therefore, he can born on any of the 6 days of 7, therefore 6 by 7. Similarly, for third person, he has only 5 days of 7 days to born, therefore 5 by 7. Again, for the last person, 4 by 7. Hence, the required probability, that is probability of the event where no 2 persons born on the same day is, by simplifying, you get 120 by 343, that is answer is C. Then we have to find the probability of select a intelligent rich girl. So the probability of selecting a girl is 25 by 100. Also intelligent 20 by 100, and rich is 10 by 100, because all the 3 events have to happen. Therefore, probability of the event equivalent to 1 by 200. So hence our answer is A. Find the probability of drawing a king, queen and jack in 3 consecutive without replacement. Without replacement means once you get a card, we should not put it back into the cards again. So therefore, the probability of getting a queen in the first draw, let us say probability of the event, to get the king in first. We have total 52, out of them 4, therefore 4 by 52. So we have taken a king, just we remove, don't put it back. So now we have only 52 cards and we have 4 queens, therefore 4 out of 54, 51 is the probability for getting a queen, and a jack here is again 4 by 50 because we have taken king and queen out. There are only 50 cards, therefore 4 out of 50. This is equivalent to, after simplification, 8 by 16,575. Hence the required answer is B. We are given only one die, it has to be thrown. There is in 2 trails. What is the probability of getting 3 at least once? Means it may be in first trail or in the second trail or both the trails, because it is at least once. So what we do here, first we shall find out probability of not getting 3, of not getting 3 in first trial, equivalent to 5 by 6. Similarly, probability of not getting 3 in second trial, because both are independent of each, therefore 5 by 6. Now I can find out probability of not getting 3 in both trials, equivalent to by 6 into 5 by 6, that is 25 by 36. So here probability of not getting both the trials is 25/6. Therefore probability of the event of getting at least once is 1 minus 25 by 36, that is equivalent to 11 by 36. Therefore B is the answer. Probability of A speaking truth as 60%. Let us say PA equivalent to 60 by 100. That means 6 by 10. That is 3 by 5. Where PA dash will give you the probability that A do not speak truth. That should be 1 minus 3 by 5. That is 2 by 5. Similarly, probability of B speaking truth is given as 25%. That means 1/4. And the probability that B do not speak truth, let be PB dash, is equivalent to 3/4. The question here, we have to find the probability that they are likely to contradict each other. Means if A speaks truth, B should not speak truth. If B speaks truth, A should not speak truth. Therefore, the required probability that means if A speak truth, B should not speak truth, or if A do not speak truth, then B should speak truth, equivalent to 3 by 5 into 3 by 4 plus PA and PB dash. PA dash is 2 by 5 and PB is 1 by 4th. Simplifying, we get 55 by 100, that is 55%. Therefore C is the answer. We are given 15 tube lights and we need 3 tube lights to light a room. Therefore sample space, that means taking 3 tubes out of 15, so 15C3. But out of 15 tubes, 6 are defective. If you take any 3 tube lights out of 6, the room cannot be lighted. So therefore, I can find the probability that room is not lighted should be 6C3. That means if you take any 3 out of 6 defective lights, room is not lighted, divided by total number of outcomes, that is 15C3. So the above probability will give you that room is not lighted. Hence the room lighted should be 1 minus 6C3 by 15C3. So this, by working out, we get, so that is equivalent to, this is 4 by 91, so equivalent to 1 minus 4 by 91 equivalent to 87 by 91. Our answer is D. Find the probability that the sum of the numbers you take 2 at a time from given 12 natural numbers should be divisible by 3. So therefore the sample space in this case is, that means taking 2 at a time out of given 12 is 12C2. Out of all the, what I can say, outcomes, how many are there? The sum should be divisible by 3. So it should be divisible by 3 means the sum may be 3, 6, 9, 12, 15, 18 or 21. So here we have to find two numbers such that their sum should be any one of the above. Therefore the possible outcomes are 1, 2, 1, 5, 2, 4, 1, 8, 2, 7, 3, 6, 4, 5, 1, 11, 2, 10, 3, 9, 4, 8, 5, 7, 3, 12, 4, 11, 5, 10, 6, 9, 7, 8, 6, 12, 7, 11, 8, 10, 9, 12, 10, 11. So here the above list contains contains 22 which are divisible by 3. See, therefore the probability that the sum of the numbers divisible by 3 should be 22 favorable events by total number of events is 12C2. That is equivalent to 1 by 3. That is B is answer. Here is of radius r. A point is said to be closer to the center if it is within or less than r by 2. That means if it is r by 2 or less than that. If it is above, it is closer to the surface. So therefore all those points which falls within the volume of radius r by 2 are closer to the center. So therefore those points can be calculated as 4 by 3 pi r by 2 cube. So these points, that means points within, closer to the center are here. So therefore the probability of the event, that means the points chosen which are closer to the center, is given by 4 by 3 pi r by 2 whole cube divided by 4 by 3 pi r cube, that is total volume of the sphere. Simplifying, we get r cube by 8 into 1 by r cube. Therefore that is 1 by 8. Now the question, we have to find odds in favor. So therefore probability E dash equivalent to 1 minus 1 by 8, that is equivalent to 7 by 8. So odds in favor is defined as PE is to PE dash, that is 1 by 8 is to 8 by 7, that is 1 is to 7. Hence your answer is A. Probability that of drawing a king in third draw. Also given spades are removed, therefore total number of cards is 52 minus 13, that is 39. And kings, the number of kings in these cards should be 3, because spades are removed, spade contain 1 king. So when we want to get definitely in the third row, let us say what is the probability of getting king in the first draw is 3 by 39. That means I get 1 by 13. Then what is the probability of not getting in the first draw? We can calculate. So therefore probability of not getting in the first draw equivalent to 1 minus 1 by 13, that is 12 by 13. Similarly, because here we are drawing the king without replacement, hence probability of not getting in a king in the second draw should be 1 minus 3 by 38. 1 minus 3 by 38. Yes, because we have taken not getting. So therefore it should be equivalent to 35 by 38. Similarly, we can find the probability of getting a king in the third draw equivalent to 3 by 37 because we have removed one king, one card earlier. So 3 by 37. So now I can write required probability of getting a king in the third draw should be equivalent to first draw not getting is 12 by 30. We should not get in the second draw 35 by 38, and getting in the third draw should be 3 by 37. So simplifying, I'll get 630 by 9139. Number of students given is 30. Students is 30. That means 17 girls plus 30 boys. Out of them, 5 are A plus students and 3 of them are girls. We have to find the probability that choosing a girl or A plus student. So let us say probability of choosing a girl is 17 by 30. Probability of choosing A plus student is 5 by 30 because 5 are A star students. Now among 5, 3 are girls, therefore I can write here probability of choosing A plus girl. It is given 3 of them are A plus, so therefore 3 by 30. So here I can take choosing a girl may be a PA and choosing a plus student may be PB, and this should be probability of A intersection B. That means both a girl and A star student. Therefore, the probability of choosing A or B, either a girl or A star student, is PA PB minus PA intersection B. Therefore, 17 by 30 plus 5 by 30 minus 3 by 30. So 17 plus 5 is 22, 22 minus 3 is 19 by 30. Answer is C. Consider the number of people be 100. People are 100. And people wearing tie. Wearing good tie 25%. Therefore, it is 25. Now we are taking 3 people at a time. Therefore, sample space, that means possible outcomes are 100 C3. But we have to find the probability that all the 3 wearing ties. So number of arrangements of all the 3 wearing ties, number of ways of getting all the 3 wearing tie is 25 C3. Therefore, the required probability that equal to, after simplification, 1.42%. Therefore your answer is B. We are given green and red balls in the ratio 1:5. Therefore let us consider that there are x and 5x green and red balls are present. Now we add equal number of green and red balls, that is y balls of each color is added. Therefore the total number is, now the total number is balls is initially 6x plus y number of red balls and y number of green balls, let us say 2y, is the new total of balls present. It is given probability of getting green ball now is 1/3, which is equivalent to x plus y, x earlier green balls, y we added, by total number 6x plus 2y. This implies 3x equivalent to y. Therefore the ratio of total number of balls added to the original is, that is 2y by 6x. 2y were added later and 6x is originally we had. Therefore that is equivalent to y by 3x, where we know y equivalent to 3x by 3x equivalent to 1. Hence the required answer is D. We are given totally 6 numbers from 1 to 6. Total numbers be 6, that is 1 to 6. 1, 2, 3, 4, 6. You have to choose 2 numbers at a time. Therefore number of ways of choosing 2 numbers, that is sample space, is 6C2. Now we have to find that in how many ways we can choose 2 numbers where the least number among the selected numbers should be less than 4. Let us consider one on, let us consider one and other number may be 2, 3, 4, 5, 6, because 1 is definitely less than 4. When you choose 1 with any one of the other numbers 2, 3, 4, 5, that is in 5 ways, definitely one among the two numbers is less than 4, that is number 1 is less than 4. Therefore, number of ways of choosing one number less than 4 equivalent to 5. Likewise, consider 2 and other numbers may be 3, other numbers may be 3 or 4, 5, 6. So one of them is 2. So with any one of the above 4 numbers, so therefore number of ways choosing one number less than 4 in this case is 4. Likewise, consider 3 and other numbers may be 4, 5, 6. Hence, number of ways of choosing one number less than 4 in this case is 3. Again, next consider if you take 4, so it cannot be less than 4, hence we can stop. So total number of favorable outcomes in this case are total number of favorable outcomes is 5 plus 4 plus 3, that is 12. Therefore, the probability, that is E, of choosing one of the two numbers less than 4 here is 12 by 6C2, which is equivalent to 12 by 15, that is 4 by 5. Hence your answer is A. 1 cards from 1 to 100. So 2 cards are chosen at random. Therefore, sample space is 100 C2. That means 100 to 99 by 2 into 1. Now the question, in how many ways we can choose two numbers which are consecutive? Means the numbers may be 1, 2, 2, 3, 3, 4, 4, 5. So it may be up to 98, 99, 99, 100. So therefore, if you observe here, totally 99 favorable outcomes are there. Favorable outcomes, that means two consecutive numbers we can get 99. So therefore, the probability of the event, that is getting two numbers consecutive, is 99 by 100 C2, that is total number of outcomes. Therefore, I can write 99 by 100 C2 is 100 into 99. 2 will go to the numerator. So after cancellation, I will get 1 by 50. Therefore, probability of the event of choosing two consecutive numbers is 1